Hey everybody, here we are with our final chapter. My favorite topic really, raster analysis. So we're going to be getting into rows and columns, doing things in raster world. So this will be pretty cool. There's a saying we like to use, a raster is faster, vector is corrector, and nothing is more true than that, I tell you. Um, we had a chapter earlier on working with raster data, and now we're going to work on things we can do with the raster data model that is sometimes really difficult to do with polygons. So remember, raster data have this unique storage model, and it's based on numeric arrays. Every pixel, every cell has a integer value, and that's how that works. Um, the format, it allows a whole different kinds of analysis techniques we can use, and it can be quicker depending on what you're doing. But one thing to keep in mind is when you're doing raster analysis, you're relying on distances or areas a lot of the time. We count up cells to do areas, for example, and so you make sure the data are stored in a projected coordinate system. And we'll talk a little bit about projection and some of the implications there with raster data. There are raster types, really two main flavors. Remember, there are discrete rasters that store object categorical data like objects, and that's like land use polygons. Or if we take some road vectors and convert them to raster, then every cell is either on a road or in no data, off in space. And then we have continuous rasters. They have something that changes over, like elevation or annual precipitation that's been interpolated and things like that. And often, this projected thing, you got to worry about that. We can get in big trouble if we're calculating number of cells that are in a certain land cover and we're not in a projected coordinate system, because then we get square degrees. It doesn't help us very much. A lot of these tools are worked with in ArcGIS in a subset, or what we call an extension called Spatial Analyst. So we fortunately have a license that includes pretty much everything in ArcGIS that's available. Spatial Analyst it's an add-on that people buy the core software and then they add this on, and it does raster analysis. So it extends all the tools that you've got. A couple of tools are what they call core, which means every copy of ArcGIS has access to that. An example would be the clip raster tool, and the mosaic tool, some of these tools that work with rasters. But to do analysis on rasters, you need to turn on this extension. And what's kind of nice in Pro is that that's kind of turned on in your license side of things. You never worry about it. In ArcMap, there's a button you got to check to make sure Spatial Analyst will work. An important thing about all these tools is we have to worry about that environment. And we've worked with environments before, like the default output coordinate system you have or the default output workspace. And this environment setup actually first was developed as part of the software way back in the day on the raster side, because when you start putting rasters together, you have to make decisions about how you're going to combine them. So some of these environment settings become really important. We've seen these before with workspace and processing extent. What's new to raster is the output cell size and the mask. So we'll show you what those are all about. So the workspace, we've seen this before. When you set up a project, there's a default output workspace, and that's where things go. And when you're doing a lot of processing, often you'll have a temporary space where you can save things, and that can be a folder or a geodatabase. So often you might have a junk folder that you can clean up from time to time. You might put the scratch workspace there. So this is really important. By default, you really don't worry about it because these workspace settings are set up when you first set up your project. Output coordinates control the output coordinate system, but often projecting raster involves resampling, which we'll talk about again. It's not a good idea to change coordinate systems. So really, when you're setting the output coordinates, you want to make sure they're set up to work that way. So the setting for raster analysis, you want it to be blank because you really don't want to project on the fly. And I'll show you why later. We'll do a little demo to show you how that works. Processing extent is really important. Rasters are always, because they're row column, they always make a rectangle. Unlike polygon data sets, there's a box, and every cell within that box has to have a data or no data value and all that. But when you put data sets together with raster tools, if they don't match, this option will determine the output extent. The default for most tools, okay, is the intersection of the inputs, because those are the ones that have meaningful values. It'll just be no data outside there if you're combining two rasters usually. So best practice is to choose one of your rasters as to be that processing extent and force all outputs to match it, including that snap raster. Um, and so if you set the extent to be a raster and the snap raster to be that same raster, everything will all line up. Here's that cell size setting. If you have two raster inputs that don't match, a 10 meter and a 20 meter raster, the maximum for most tools, the default is usually maximum inputs, which means if you combine a 10 meter and a 20 meter raster, you get a 20 meter raster out. So you can go ahead and set a consistent cell size so that works. Another important environment settings working with rasters is the mask. And a mask can be used to clip all output to the area of interest. So say you're working in a watershed, no matter what raster tools you use, if you set the mask, all cells outside of your mask area you set, which can be a polygon or a raster data set, will be set to no data outside that. So we mentioned resampling. It comes up a lot because raster processing requires these outputs to match. So when we do an overlay, things get resampled before we combine them. So we want to avoid automatic resampling. You really want to use consistent extents so you don't need to resample more than you have to. And there's automated resampling that happens when you put two tools together, with two rasters together, and that is going to be a nearest neighbor resampling. That's kind of what we're seeing here. So no new values get created. In some situations you want to use bilinear, which will estimate between the cell values. Imagine an elevation raster. In that situation, you definitely want to make sure that the resampling is set up that way. So we don't do it on the fly. We do it ahead of time using the project raster tool, for example.